I'm mentioning for those that just came in, I'm not looking for business. I'm retired. I enjoy doing repairs. I do repairs. I'm an advocate for learning to do your own repairs. And there are many people in the club. Northern TV, Views Audio, there are a number of people who do repairs. So I encourage you to do that. I'm happy to do repairs, but I'm not seeking, I don't need to do it for a living. So what are we going to be discussing? Well, I'm going to talk about some thoughts about receiving and collecting on receivers. Then I'm going to talk about repair, set up tools, test equipment, and then some common repairs you're going to encounter when you get into this old equipment. And some suggestions for the technician. You might find something that you'd find interesting for your own efforts. So why all the interest? Well, in the case of old stereo receivers, there are a lot of choices. The equipment really does sound good. Come on, we admit it. Kids just don't know these days. It doesn't stream, it doesn't Bluetooth, but boy does it sound good. It really does sound great. There are a whole bunch of styles to consider. In the early days, they came with a chassis with the tube sticking on top, and then it became low profile and they had the brass fronts, and then you went to the chrome fronts, or the brushed aluminum fronts, and then the blackout fronts with the brushed aluminum, and then all kinds of interesting things. And then the full blackout. These days, of course, they're all dull. It's a black panel and black knobs and a little digital display to look at. And the equipment is technically interesting. A lot of it was state of the art at the time. And it's kind of fun to work at it and say, what was the engineer thinking when he was working on this thing? Vintage audio equipment tends to be, in fact, is almost exclusively all analog linear processing. There are no digital artifacts. Keep in mind that everything in the audio chain, from cartridge to amplifier to speaker, or from tuner to amplifier to speaker, to one degree or another is going to color the sound, speakers in particular. It's going to affect how it sounds. And equipment choices will affect the color. I've talked to people who have the nice big old Klipsch speakers. Klipsch speakers were made as a horn because that's a much more efficient, acoustically efficient design. So the power, sound power on a horn speaker is much higher for a given input than it is on a bookshelf or a small compact speaker. Of course, they go all the space. But those speakers will sound great with a tube amp. Solid state amplifiers tend to have a lower output impedance and therefore damp the speakers. And it sounds, people call it dry, or it sounds dry because it doesn't bring out the resonance of the speaker as much. It has to do with that coloration. And the other thing is I wanted to mention, vintage equipment can and will be the subject of age. And that is, there are components in there that fail just simply from sitting around. Off the air is still free. Can you imagine that? You have to put up with commercials. But it's still free. You don't have to pay a monthly subscription fee. Vintage receivers are actually quite good from a technical standpoint. In fact, FM tuner performance peaked in the 70s. That's when they had the frame grid RF amplifiers and then the Nuvistor RF amplifiers, cascoded Nuvistors and cascoded frame grid tubes. And from a noise perspective, those had the best noise factor at the time. And at the time, they were better than gallium arsenide FETs. These days, you could make a better one, but for economy reasons, who listens to radio? They just don't. So those FM tuners of the 70s will be quite good. In fact, better than what you're going to go down and buy now. Of course, they don't do surround sound, and they don't have the optical input. Okay, anyway. This is an important point. Your personal perception of sound and your taste in music, or what sounds good to you, is as personal as your fingerprints. It's as individual as your fingerprints. So what sounds good to you, so what sounds good to me, may be different, but go with what sounds good to you. It's It's just that simple. And in comparison, when you're listening to two things side by side, if it's the same signal, if I just have a switch to switch it up and down, same signal, same everything, 3 dB higher, the louder signal always sounds better. It has to do with the Fletcher-Munson curves and your personal perception of hearing.
Is that what the loudness button was for?
Loudness button, that's what the loudness button is for, because as the level goes down, your hearing bandwidth narrows. And human band hearing peaks at about the frequency of a woman's voice. And that was for survival reasons, because you can understand when somebody said there's a lion, run, you could understand it, even if you didn't, you just barely heard it. And then as the sound gets louder, the bandwidth increases. So the loudness control is designed to boost the highs and lows to compensate for that, so you can hear your full range. Unless you're my age, in which case you don't hear the highs, so it just happens. And this is where I get to try to avoid what's called the ever so much more so effect. Ever so much more so comes from a series of books written by Robert McCloskey in the late 40s. I loved him reading them as a kid. And it's Tales of Homer Price. And in a little town, little Midwestern town. And they had a hawker come into town who was selling a product called Ever So Much More So. And it came in a can that was about the size of the shaker you use for powdered sugar in the kitchen. And it was ever so much more so. And you took the can, and if you're having bacon and eggs, you sprinkled it on your bacon and eggs, and they tasted ever so much more so better. And if you sprinkled it on your AM radio, it sounded ever so much better. And if the car was running rough, you could sprinkle it on the engine, and the engine would run ever so much better, ever so much more so. And finally, the kids started to figure out this out, and took the can apart and figured out, of course, there was nothing in the can. And the ever so much more so effect comes from, well, the transformer's wound with silver wire, so it must sound better. Okay, it's your money. It's so you want to avoid that effect just because it has a fancy brand name on it, or because it's wired this way or that way. Audiophiles can hear the wire, and with all due respect, I don't think they can. So enjoy what you enjoy. Take the advice, but always allow that somebody's applying their perceptions, not your perceptions. Tube or solid state. A lot of people really do prefer tube sound. It does. Tube-type amplifiers tend to have a higher output impedance, so that you can hear the resonances in the speakers more. Tubes aren't quite as linear. There's slightly higher distortion, and it's a pleasant distortion for you often. But it's only slightly. Tube amps really do sound really good. Downside you pay for that is tubes do have a life. It's like an old incandescent light bulb. It's going to fail with use. And replacement tubes, if you haven't noticed, are getting scarce and are getting expensive. And particularly for people who are looking for things like the Telefunken tubes and that, I will be sure to apply the ever so much more so principle. Tube-type amplifiers, as a general rule, tend to have lower output power. RCA kind of broke it open in 1938 by introducing the 6L6, and the 6L6 allowed you to get like a 30 or 40 watt amplifier with somewhat less lethal voltages under the chassis. Of course, Western Electric were making very powerful amplifiers, but they were putting upwards of 800 volts on the plate. So tube-type amps, generally, you can get a 100 watt channel solid-state amplifier pretty readily these days, even from the 70s. Tube-type equipment consumes a lot of power and requires ventilation. tubes themselves get hot enough to raise a blister with one touch. And tube type equipment, if you haven't picked it up, for some solid state is too, it's heavy because they have big transformers. And big transformers are there for broad frequency response, particularly bass response. And good transformers are big and they are heavy. So there's your tube types. Of course, what everybody likes about a tube lamp is that they glow. You really do. You hope they glow kind of this color and don't do bright blue flashes and other things like that, because that's an indication of potential failure. Solid state stereo receivers from the late 60s and on into the 70s and early 80s are really quite good. And the equipment has an exceptionally long life, and problems are usually from age, things sitting around, and not from use. For the most part, repair parts are generally available at a reasonable price in solid state equipment. The exceptions, of course, are things like switches and specialized stuff like the band switch or the selector switch and that kind of stuff. But the capacitors, the resistors, transistors, that kind of stuff is pretty readily available. And as we discussed earlier, there's a lot of choices. So here's some choices. If you want to go to it, that Marantz in the up in the upper right-hand corner there, that Marantz is a Model 18, which had, instead of a tuning eye or tuning meter, it had an oscilloscope, which would let you really tune the thing in. It's really a very, very clever, very ingenious gadget. It's the last receiver that Marantz himself had anything to do with it. And it's also an interesting and complex thing to work on. And the bottom one here, the SX1010, the Pioneer, that, if you'll notice, that I put in the blue glow LED dial lights, and it really looks sharp. Those blue lights, if it's your taste, really look sharp. You can also get ones that are the regular color. So let's talk about repairs. My personal perspective is repair work can really be rewarding. You get a certain endorphin rush when you get this stupid, I found it, it's working. Old equipment can and will require repairs. And I have my usual caveat for people who are doing repairs. Old equipment often contains materials known to the state of California that cause cancer and birth defects in lab rats. They have lead in there, leaded solder, and cadmium plating, and chrome, and stuff like that. And it should also be noted that particularly tube-type amps have lethal voltages underneath the chassis. And tube-type equipment will have hot surfaces, and as they say, potentially lethal voltages. Just keep it in the back of your mind. It's unpleasant. It will burn a hole in your skin. It smells bad, and it hurts like anyway. Not that I ever. Anyway. I have some suggestions for a workbench. And you can do with this as you will. I'm going to grab something here if I can find it. I have sorry guys, I meant to get this out. I should have gotten this out. Got it with my, I was hoping to use the cursor on this the computer screen, but I don't think I can do it while I'm doing a presentation. At any rate, we'll start while I'm fumbling around up here. The bench should be well lit. I highly recommend good lighting. The bench should be a comfortable height. Height for me is generally about waist high, because when you're loading something heavy onto the bench, you want it to just slide in there. I have next to my bench, I have a cart that is the same height as the bench, and that's on purpose. I have a cart that's the same height as the bench. Sorry, please. That's okay. He's getting a picture of me. And that can be very useful. Test equipment should be readily accessible. where you can see it and lay hands on it. Tools should be readily accessible. The bench in the cart should be sturdy. And I happen to have on my bench, it's on its own breaker. I learned this very early on, and learned the need of another thing. It's working on a hot chassis radio. And without thinking about it, I connected the ground probe of my scope to the chassis. Well, the chassis plug was in, the chassis was hot. The scope lead, and of course the ground on the scope, was neutral. And then I was sitting there blinking from the flash in the dark. So there's several morals in there.
Did the scope get destroyed?
No, just the ground plug.
Oh, okay.
I was fortunate in that case. So here's a bench suggestion. This happens to be my workbench at home. And I can point out a few things here as we go through here. I have first here's my rolling cart. And in this case, the rolling cart has the DUT, the device undergoing testing part here. That's the fancy engineering term for what it is. That's a device undergoing testing. Across the top here, I have my Heathkit scope. It's only a 10 megahertz single tray scope, and for just about everything, that's completely adequate. It's easy to use and handy. I have an old VTVM that actually dates to 1959. I built it from a kit with my high school science fair winnings, believe it or not. And it has been turned on ever since.
What?
I have never turned it off. I've had to replace the tube, but it remains very stable that way. The calibration holds. I have a ICO signal generator, RF signal generator, that I modified a little bit to make the dial more accurate, but it has been, and also not new. It's tube type, but not new. I have a frequency counter. Also, it happens to be a Heathkit, and very handy. When you need it, a frequency counter is useful. It's not essential, but it's useful. I have an audio generator. If you're going to work on hi-fi equipment, you do need an audio generator. And over here, I have a sweep and marker generator. And you do not have to do sweep alignment. And this is still useful because it has crystal controlled oscillators in it, including a 10.7 megahertz oscillator that's crystal controlled. I can use that as a signal source, and I don't have to worry about, is it 10.7, is it the FM/IF frequency. I have here my bench receiver. It's just a general purpose AM/FM stereo receiver. And that is handy because it has inputs and outputs that I can use for testing things. Therefore I always have a tuner on my bench, and I can always feed a power in with that. Back here, I have a HP analog multimeter. Analog meters are very useful for doing alignment, where if you're looking for a null or a peak. I can never remember when a digital meter was the number bigger or smaller when it changes. It has to do with the tension span, I guess. I have a Variac, very useful device to have, so you can sneak up on voltages. I have a good digital Fluke multimeter, and I'd recommend that. I have hiding in here. There is a temperature control solder iron. Strongly recommended. They're expensive, but after you've used one a while, you won't go back to a temperature control one. I have a signal tracer. That's a phono amplifier with an isolation transformer and a speaker in a box. Very handy to have from time to time. It's a tube type, so it's high impedance. Of course, you need a device, you need your tools. It's always handy to have a pen light, AA pen light on your bench. And down here, you see here, these jacks here are connected to a power supply which is tucked in under the bench. So I have a readily available 5 plus or minus 12 and 24 volt supply that happens to be an old computer power supply. The advantage of that sucker is that it's linear and therefore doesn't make switching noises and interfere with radio while you're working on it. And then I have here speakers, my bench speakers, which are in the rafters over my head. So they're out of my way, but they're readily accessible there. And that explains this tangle of wires over here, because every time I work on something and need to make a new wiring harness, I make a new wiring harness that plugs into the speakers, and it just hangs there for the next time. So that explains this, and I've got a tangle here. These are fuses, and then of course the clutter of tools you get whenever you're working on something. The bench, by the way, I put an addition on my house, and it's the surface is the 3/4 inch plywood underlayment, and the construction is all 2x4s and 2x6s, and it's bolted together so it can be moved. But sturdy helps. On top of the plywood is a piece of tempered masonry. And believe it or not, at one time it was painted white. And white makes it easier to find things. So, what do you need? Good assortment of screwdrivers. Phillips from the 00 to number 2. I very seldom needed anything bigger than number 2 working on electronic here. Flat bladed screwdrivers from big to little. Allen wrenches in ASA and metric sizes. A set of Allen wrenches is invaluable, particularly if you're going to take off. It's amazing the number of knobs that used Allen wrench set screws. And that they can be very handy. There are other things that are held together with Allen wrenches too. Set of spin tights, otherwise known as nut drivers. Spin tight is an old brand name. ASA and metric. Set of needle nose pliers, very useful. In fact, a couple of different kinds are useful. I have a flat pair of pliers, like a duck bill. It's very useful for flattening things out or bending relay contacts or any number of strange things. And even a channel lock comes in handy. I've got little channel locks. It comes in handy from time to time. And of course, you need diagonal cutters. Wire stripper, I highly recommend wire strippers. You can do the risk your thumb rolling. Did I just knock myself off the air? I don't think so. You can do the rolling the wire under your pocket knife to strip it. I don't recommend that. It puts your thumb in peril. So you want a wire stripper. And wire strippers, a hemostat is very handy, particularly if you're doing dial core, because it'll clamp something and hold it. And the hemostat also doubles as a heat sink when you're soldering wires. Vice grip. Connector crimper is optional but very handy to crimp the fastons and lug rings and so forth. You can solder that stuff, but it's nice to have a proper crimping tool. Set of calipers just to measure stuff. What size is the shaft? Set of scales, the little one, 6 inches fine. It's English and metric. And you want a drill motor and drill bits. I think just about everybody has a drill motor and drill bits. You want tweezers, very handy for doing dial string and picking up stuff that you drop down into the chassis where you can't reach it. Dental tools. I have a set, I got it in Army Navy surplus. The dental tools are wonderful desoldering aids. You can use them to dig stuff out, and solder doesn't stick to them because they're stainless steel. Spline wrenches, they look like an Allen wrench, but there's a star pattern, and this isn't necessarily Torx, are very useful, again, because there are set screws that use spline screws. I also have, I didn't put on here, a set of security bits, because there are some pieces of equipment where for safety reasons, the screws are all security bits, so just to get the back off, you have to take them off. A quarter socket set that metric can use. Sockets is useful. A pair of true arc pliers are seldom used, but they're very handy. Those are the things that spread those C-shaped washers with just little eyes to get it, to squeeze it together as push it apart. And a set of calipers. Soldering iron, I mentioned that. Temperature control is best. I use a 40-watt temperature control, which is lovely. I have a Weller soldering gun. Old-fashioned Weller, sometimes you need more heat, and it's right there and ready to go. I have an American Beauty iron you don't know what American Beauty is, the big ones. It has wonderful heavy thermal mass. Occasionally, you will encounter, not so much on hi-fi equipment, but on old radios, you'll encounter where you have solder to the chassis. And that's the only way you're going to get it done. You need a solder sucker. Mine happens to be a little funky vacuum one. You're going to need that because solder sucker is the only way you're going to get the solder out of the holes in the circuit board. If it's a double-sided circuit board and plated through holes, the only way you're going to get it handily unsoldered is with a solder sucker. And a heat gun. Amazing when that comes in handy, other than just doing heat shrink. Another tool you may not think of is camera, like your phone. That works fine. I use my camera when I take something apart because I'll take a picture of it, and golly, if I forgot how I put it together, it's right there. Take the picture before you take it off. Phone's fine. Pocket calculator. Amazing when that comes in handy. Just keep in mind, twinkle, twinkle, little star, E is equal to IR. That's Ohm's law. Twinkle, twinkle, little star, E is equal to IR. Ohm's law can come in handy if you're working on a chassis and they don't give you an expected voltage. You can use that to figure out what it should be. The double-A flashlights I mentioned, a magnifying lens, one of those portable ones on an arm that you can look, particularly if you're of an age. It's handy to be able to see things. And a very seldom used but useful tool, relay contact dressing tool. It's like a points file you used to use when you're working on your car. Oh yeah, and two most important tools, your brain and your patience. Don't, remember what I said about the rush. Test equipment, we talked about, multimeter, analog multimeter, an oscilloscope, an AC electronic voltmeter. It's handy if you're actually making power measurements on an amplifier. Audio signal generator, an RF signal generator. Sweep and marker, kind of optional. You can do sweep alignment on a radio, but usually you don't need it. Frequency counter, very helpful, very accurate. Tube checker. Yes, I did show a tube checker there. I have a tube checker. It's something I don't use all that often because you can turn the tubes bad by taking measurements around the tube. If the voltages are way off, or if the signal is going through it, you want to try just substituting a replacement. If you want to put it on tube checker, you can, but I actually don't use it all that often. Signal tracer, because sometimes it's easier to work from the preamp toward the amplifier to see where a signal's getting lost. And I mentioned my bench receiver. Service manuals are available online, and they're available for free. Part sources are online too. And if you can't find an exact manual for what you're looking for, look for similar topology or same manufacturer, different generation. They frequently are quite similar. And when searching for manuals on parts, be web aware when you're searching, because there's some very nasty things lurking out there. Let me go back here. This happens to be a typical website. You want to be sure to click down here for where you're looking, if you're looking for a manual. Do not click up here where it says download now. If you see a download now on the website page, they have to pay for these pages somehow. And that's how they pay for it. And you will spend an hour or 2 or 3 or 4 getting the crap off your computer that button will bring you. So that's just a caution. As I say, there are a lot of good sites out there, and those are free. But beware the download now button. Because they will download it, and you'll find yourself entangled. It's even worse if it asks for a credit card. Obviously, that's when you really panic. I'm not going to discuss alignment in my discussion here, because that's kind of a whole other seminar. Fortunately, these particularly solid state ones, the alignment is very stable. It's probably okay. Now, the receivers we're talking about are 40 to 60 or plus years old. So some of them have been exposed to what I call unfortunate storage. I had a receiver on my bench just last week where it had spent about 40 years in the garage, an unheated garage. At least it didn't have any mice in it. I have had ones that the mice have gotten into. I have had ones that have had insect infestations. So you do want to be a little careful if you get that wonderful barn find that you might have six or four-legged passengers in there. In fact, I had somebody bring me a car radio that was, it's the only time I've ever seen it. In fact, last week I had a car radio that somebody brought me that had honeycomb in it. It was wonderful. It was a sticky, ooey mess. The bees are long gone, but the honeycomb remained and the honey was unfortunate storage. Electrolytic capacitors, let's talk about that. That is a really common, electrolytics is a really common failure. And they fail with age. Electrolytics are called dry capacitors, but they really aren't dry. So one failure mode is that the electrolyte that's in there simply dries out. The moisture escapes, depending on how well sealed it was. And the older it is, the less likely it was to be well sealed. And they will develop leakage, go open because it dried out altogether. Or worse yet, they'll short unexpectedly. On electrolytics, notice they said mind the ratings and tolerances. When you replace an electrolytic, particularly a filter capacitor, you might be tempted to put in a much bigger one because figuring you get better filter. For example, if it has a 10,000 microfarad capacitor for the filter capacitor in a solid state unit, you might be inclined to put in a 18,000 or 20,000. You might find that the tube type amp that it had a 80 microfarad capacitor, and you might be tempted to use a 150. Don't. The reason you don't want to mind making it bigger is not better. By making it bigger, on a particularly power rectifier, you increase the peak current on the diodes, solid state diodes. Or in a solid state, or in a tube type, you're increasing the peak current on the rectifier tube. And high peak current on diodes will kill them. And high peak current on rectifier tubes will eat the cathode right off of them. So bigger is not necessarily better. Try to get within about 20%. On ratings, there are 4 ratings on electrolytic capacitor combined. One, of course, is the voltage. You certainly want the new one to be at least equal to the rated voltage of the one you're replacing. It can be a bit higher. You don't want to go too high again here because electrolytic capacitors depend on the voltage upon them to maintain the form. And the form refers to the fact that that electrolyte that's in there, when there's a voltage put on it, will cause a layer of oxide to form on the plate, the aluminum foil. And that oxide layer is actually the dielectric. So the electrolyte is the conductor and the aluminum plate behind it. And the oxide layer, that little atom's thick oxide layer is the insulator. And that you want to be formed for the voltage it's rated for. Because when the manufacturer did the capacitor, you put the appropriate amount of goop in the solution to form just the right thickness of layer. You, of course, want to check the capacity. We talked about that. But there's also temperature and light. Yes, sir?
I have a question about voltage. How much higher can we go? Like if let's say if the schematic saying 250, can we go 450?
The modern 450 volt capacitors will be fine. For a 250 or 350 volt application, modern caps will be fine.
For tubes?
Or
For a tube amp?
for a tube amp, yes. And conversely, on a solid state amp, it might be rated 65 volts, and you could go easily to 85 or 90 volts. on the rating. In fact, I've encountered some solid-state amplifiers. A little tip to keep in mind, some of the Japanese have a adjustment on the back for line voltage. And one of the bright souls that owned one of these that I got had discovered that if you turned that line voltage switch to 110 volts, you got more power out of it, which you did. However, when you do that, when you plug it into the outlet, here, Edison delivers to my house at about 123 volts. So it's quite a bit over voltage. And the capacitors in the power supply were rated right at, assuming that it was exactly 120 volts for 120 volts, or 110 for 110. And the 73 volt caps were running about 80 volts, which is hazardous. And in fact, it caused a failure. So you can go up in voltage a bit. The temperature life ratings, caps originally were rated at 1,000 hours at 85 degrees Celsius, meaning it could run at 85 degrees Celsius, it would generally last 1,000 hours. My replacements I get are rated for 105 degrees Celsius and 3,000 hours, if I can find them yesterday.
You know, I've done some work on old military equipment, tube equipment, you know, and a lot of the capacitors are rated at like 600 volts. But as far as I can tell, in the circuits, they're never going to see 600 volts.
Yeah,
So can I downgrade
for
them?
the signal capacitors, that's fine. For the like bypass capacitors or coupling capacitors, that's just fine.
So, you know, they've got those bypass capacitors rated at 600 volts, but let's say the circuit is going to see 200. Can I derate them and use maybe 300 volt capacitor?
You can. I would. I mean, these days the 630 volt cap is very close to the same price. And it's physically going to be a lot smaller than what's in there anyway.
Did they do that because back in the day, the capacitors weren't that good?
Well, they did, yeah, they figured it made it more reliable. Now, a little tip about those capacitors in the military. That some of the military gear, the capacitors came in a little metal can with the lugs on it, which is supposed to be hermetically sealed. There's still a paper cap in there and it's leaky as sin. It will be bad. That also goes for Scott radios. If you're into the big Scott radio, those can capacitors in there will be bad. But on electrolytics, be sure to check temperature of life. Just the longer life is better. Positive thing about electrolytics these days is the new ones are physically much smaller. They don't take up as much space. So,
How do you check to see if the electrolytic is bad?
you can generally the dead giveaway. There's two tests. One is you measure ripple voltage with the scope, and if it's going open or going high series resistance, the ripple voltage will be very much higher than what it's called for. And usually it's just a couple of volts with no signal. You're only expecting at most a couple of volts of ripple. That's test number one. Test number two, if that capacitor is running warm, it's leaky. And I find that's the biggest dead giveaway. You grab the can and it's getting warm. There are expensive capacitor checkers that measure actually series resistance and leakage. If the thing's getting warm, it's time to change it. If it's not getting warm and the ripple is low, it's probably okay, and it probably will be for quite some time. And as I said, the replacements are physically much smaller.
Do the electrolytics, are they usually the culprit that causes a problem?
They're particularly in vintage tube type equipment, electrolytics are very failure prone. Because frankly, back in the 50s and into the 60s, they didn't seal them below well. They didn't get the seals to keep the electrolyte from drying out. So they will fail with age, and they'll lose their form. And some people will hold to that you can reform a capacitor. You can get that dielectric barrier back in there by bringing the voltage up slowly. You're welcome to try it. I personally have not had a great deal of luck. I know people who have.
I hear they're talking about phasing out axial and going down radials or that other way around.
I just use, I personally just use axial capacitors
Right, okay.
and just turn the lead sideways.
Right.
And they're smaller anyway. Now, if you're concerned about physical appearance, you know, you got to have the exact look.
Well, sometimes even like you say with the radio receiver, you know, are the pins going to match the existing?
In the case of a circuit board,
Yeah.
they won't. So you're going to have to take your needle nose and very carefully bend a little set
Better to
shape.
have them off the board just so that the heat's not going to the board too.
Yes and no. Yes, it's off the board. If they're down on the board, it'll take physical vibration better.
Okay.
So if you're going to bang it around shipment, it might bend a bit, but generally that's not a concern.
There's silicone underneath there somewhere.
I just don't, you're not gonna load it on a jet, on a jet engine and let it run, vibration get to it. You're not gonna have it on a tugboat with all that diesel vibration. You're not gonna put it in a tank where you're worried about vibration.
Thank you.
So here's some suggestions on rebuilding electrolytic. First step, and this is to carefully unsolder the component of the wires. That's where those dental tools come in handy. And then, remember I mentioned the duct build pliers is very handy for twisting the twists on the capacitor to get it straight. So once you get the capacitor off the board, or off the chassis in this case, you carefully clean the lugs off and straighten the lugs. So you can straighten these very nicely. You might have to use your solder sucker and then bigger soldering iron to get the solder off, because usually there's one of them soldered to the chassis to get that solder out of there. But you can get it off, and then put it in your vise, take a hacksaw, and just cut through the can all the way around. And you notice in this case I left a lip. I have a reason for that. Then you slide it apart, slide the guts out. You want to clean the can and base. Wear gloves. This stuff is nasty. So you want to wear gloves when you're dealing with this stuff because it's, well, nasty stuff. You might also find in here that there's some asphalt to fill the can. That's where the heat gun comes in, to get the asphalt melted out of there. Then you clean the base. Q-tip with water. Am I being interrupted, or are you?
I'm just delivering a message.
Okay. I'm being instructed to move quicker. Okay, so I will see if I can get through here, because they're going to be doing drawings and whatever too. So you want to clean the can and base. You notice what's sitting here? There's a small drill motor, otherwise known as a Dremel tool with a drill bit that you're going to use to drill holes, 5 holes in the base. In this case, because there are 4 lugs. Then you take your replacement capacitors. Notice in this case I have the negatives all connected common here, and the other 4 leads sticking straight up. You then carefully insert that in the holes you drilled. And you solder the positive to the lugs very carefully. Leave the ground connection unsoldered. You don't solder that till you get it back on the chassis. Then you slide the can back over and use real duct tape. Real duct tape's the aluminum stuff that you get at Home Depot and Lowe's. It's the real duct tape, it's the aluminum. And it makes a pretty good repair from an aesthetic standpoint. And then you carefully reinstall the capacitor, and don't forget to solder that negative lead that you left unsoldered so that you can get it through, because the negative lead goes on the inside and the lug's there, and then you bring it back and touch the ground lug. If you don't care about the appearance, you can just do it that way. Just mount the caps on the plug that way, and that way you keep the terminal block. The terminal block made of the lugs. Or there's another alternative where the two new caps are that much smaller than the originals, and they're just mounted on a terminal block. Or you can tuck them in under the chassis. Notice here's the old capacitor with the leads cut off. So the above chassis appearance is there. And in this case, you take advantage of the fact they're so much smaller, tuck them in. By the way, you notice these are axial. These are radial capacitors rather than axial. Here's another tip. I said here's the solid state amplifier. The new caps are physically much smaller than the originals. The originals were held in these clamps, and the clamps are useful because the wires are on the bottom of the cap. So what I did here is I took a piece of automobile heater hose of an appropriate length and slid it lengthwise and then folded it out and wrapped it around the new cap. So the clamp then grabs with the hose, provides a nice clamp on the capacitor without squishing the snot out of it. We're talking about other caps. Paper caps, particularly bumblebee caps, are going to be bad. They're going to be leaky, and you want to replace them. Generally, you can replace them with Mylar. You might want to use polypropylene caps. Polypropylene caps are appropriate for very low level signal, perhaps in the preamp section, because polypropylene is quieter than Mylar. Both are excellent dielectrics. Older composition resistors can be suspect. Composition, the old stackable carbon copper resistors will have changed value on you. And they can fail without looking open. The other more wicked thing about composition resistors, if they're rated running too close to their rating, the heat inside will carbonize the bakelite on the outside, the phenolic on the outside, and they'll go down in resistance until they actually get close to it. And that causes all kinds of mischief and can set fire to a circuit board. Ceramic caps are usually good. I usually don't worry about the ceramic disc capacitors. But notice they said, but not always. Same way is true of mica caps. They're usually good. But I've seen mica caps fail. As a caution, by the way, if you're thinking of the mica caps in a little rectangular package, they put paper capacitors in those packages too. So it may not be mica. If you're repairing a vintage Fisher, always replace these caps. These are the caps that couple to the output tube. Those caps, and we're talking about the Fisher 400s, Fisher 500s, 500A, 500B, 500C, any 800, 800A, 800B, 800C. We're talking about any vintage Fisher. Replace those caps. You're going to test them. They're going to test perfectly. And they work perfectly right up until they short. And that's the failure point. And it's going to happen. There's a high probability it's going to happen. And when it does, it's going to take out the tube. It'll actually melt the glass. It might toast the output transformer, and then you really are toast, or the power transformer. So if you're dealing with vintage Fisher, and maybe some others, but vintage Fisher, definitely replace those caps.
Are those micas or?
They are, the ones they were German Mylar caps. They're the nice ones in the clear Mylar. And they, with aluminum foil, they look great, and they test great. And then they short. And I don't know if that's because there was some porosity when they wound the Mylar, when they made the sheet that went in between. I don't know why it caused it, but I do know they short. pots, volume controls can be cleaned with alcohol. I take alcohol, I have a syringe, like a diabetic will use to inject insulin, and I fill it with alcohol. Very carefully drip in just a few drops of alcohol on the trace and work the control back and forth. And that usually brings it right around. Avoid aggressive cleaners. If you use blue shower in there, you just killed yourself, because the blue shower will take the trace right off. It'll clean it right off. It'll be gone. And then you're looking for something that may not be replaceable. Switches can usually be cleaned with deoxit. Again, be very careful. Do not just squirt switches with blue shower, because blue shower will dissolve plastic hubs. And that's pretty bad. Lubrication may be required. You may have to take it apart and lubricate it. To get the shaft sometimes out of a rotary switch, you have to use that heat gun to get the old lubrication to let go. And I've been replacing dial strings with Kevlar kite string. You can get that online quite readily. And Kevlar is wonderful because it doesn't stretch. Early solid state equipment, picking on this, this is the 1964 time frame, 63, 64 time frame, 65. For a short period of time, they used germanium output transistors. And in terms of this topology, these diodes here and here are not available. They're just not available. And fortunately, most of them I've encountered like this diode is good. I haven't encountered others. And the only fix I could find was to redo the whole bloody output section, because you just can't get those diodes. RCA came up with the diode is doped just so that its thermal characteristics match their particular output transistor. And it was designed to keep it from doing thermal runaway. And I'm just mentioning that. If anybody's got some ideas, I've heard people talking about taking another germanium transistor, just using the base emitter junction as a diode and other things, but that's one of the repairs that's very frustrating. If anybody's got a tip on that one, let me know. The bane of late 60s and 70s receivers are plastic transistors, plastic bacteria transistors. There's lots of them in there. They're low level. Problem with those guys is they have a silicon die, and the leads coming in, the little wires jumping the silicon die. And the coefficient expansion between the plastic and the wires is not the same. And with thermal cycling, they eventually pull off. And you get a transistor that goes open, you get a transistor sometimes that goes shorted, but usually they go open, or worse yet, they get noisy. It just barely makes contact. And they'll go crackle, 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 crackle. It'll work then for an hour. And then go crackle, 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 crackle. It'll go quiet. You can find them frequently with spray freeze, or warming up gently with a hair dryer, not a heat gun, to see if you can warm up and then alternate between heat and cold to see if you can locate the offending transistor. In differential circuits, replace them in pairs. You can check online, you can look up the 2SA, 2SB, and so forth ratings on the transistor online. They pop up pretty quickly. You can also go to nteinc.com, which has a great substitution on transistors. And they will produce substitution and give you a source for NTE replacements. Some caution. There are Chinese knockoffs for a lot of this stuff. I think the Chinese manufacturers, the Chinese silicon foundries, when looking for buying dies and buying the solder the masks that they used to make the ICs, and make them in essentially garage shops. And my experience is at least half of them work. I'll leave it at that. My experience, and then same way with ICs. So you want to be a little careful about that. I've got some wonderful stuff from China too, but for small signal transistors, these two transistors are from DigiKey, NPN, PNP. I've used those two transistors in a wide number of low-level circuits, and they work quite well, and they're quite reasonable in price. It's still available. Just passing, if you're looking for a substitute. In terms of adjustments, follow the manufacturer's requirements with known. For tube-type outputs, idle currents around typical 30 mils, solid-state amps idle currents typically around 50 mils. And mentioning here, tube amps can have a phase inverter, what we call a dynamic balance setting. And it looks like this. And there are 4 methods to set that control. Notice, here's the phase inverter, 33K here, and then a 25K and a 25K pot. There are 3 ways to set, or 4 ways actually to set it. The first is to measure this resistor. It should be around 33K. Make close note with your digital meter, and make this combination from here to there the same. That gets a good starting point. Because these guys, somebody's twiddled that pot. It was set at the factory, somebody's twiddled it. It's 60 years old, somebody's already done it. So set that. Second method, connect a dummy load, apply signal to the input, and just for equal peak-to-peak voltages on the 2 push-pull tubes. With a caution, the peak is going to exceed 500 volts. It's going to be typically 800 volts on a 30-watt amplifier, the peak. And mind your scope probe ratings. Check your scope probe ratings before you go doing that. Tools required: audio signal generator, the scope, and dummy load. Dummy load is atypically, I got some nice big, I have some 400-watt 8-ohm resistors that I acquired a long time ago for that. The third method is to connect a dummy load, apply a signal input, adjust for equal clipping on the output. So that as you crank up the volume, it starts to saturate, that you get equal saturation. And the fourth method is to use a distortion analyzer, and you'll be surprised how tweaky that adjustment is. Now, between the just measuring with an ohm meter and the distortion analyzer, it's been my experience it makes about maybe a 2 dB difference in the available output power. You're not gonna notice. Unless you're really particular. Solid state adjustments. There's a couple here. This is typical topology of an amplifier, push-pull amplifier. An PNP pair. And this resistor here and here, the emitter resistors, are used to detect current, overcurrent conditions, and those then turn on a transistor which clamps the output. So that's the purpose of those resistors. Frequently you will have an adjustment here. See these diodes, a stack of diodes? The purpose of the stack of diodes is to get, since it's being driven differentially, is to get enough voltage, to overcome the base emitter voltage here and down here, so that you don't get what they call crossover distortion. Because if you don't have these in here, the voltage has to go high enough or low enough to forward bias those transistors. And it'll sound like shit at low volume. Turn it up at loud volumes, it sounds great. And when you look at it with a sine wave on a scope, you see the top align, the bottom align, the top align, the bottom align. So it's called crossover distortion. That's to prevent crossover distortion. There'll be an adjustment here to set the idle current, which is set to about 50 milliamps. You notice it's a differential input. This sets the DC feedback. See this cap here isolating? This sets the DC feedback such that the output voltage should be the same as this voltage, which should be 0 when there's no signal. Frequently, there'll be a little adjustment right here so that you can tweak that to 0. So you tweak this to 0, you tweak an adjustment here to the manufacturer's specification on the output transistors, which they will do by measuring there's your Ohm's law, twinkle, twinkle, little star. by measuring the voltage across these current limiting resistors, which is usually like 40 millivolts, 30 millivolts, 50 millivolts. So you'll tweak that. This topology is pretty universal. If you look here, it's the same topology, just more complicated. There's more stages of amplification. But it's the same circuit. You still have the current limiting resistors over here. You still have an adjustment setting the bias, and you still have an adjustment here to get zero on the output. So this topology is, and I'll go back to the simpler version of it, is been around since the advent of silicon transistors in the output. And in fact, it's the same topology that's used in the ones that they have the integrated circuit output, the flat pack thing, the bazillion leads sticking out the bottom. You want to, those have the same topology inside there. And frequently these resistors are external. And capacitors, some of the bigger caps will be external on those. But it's the same topology. One of the things I've been doing, if you get a short out here, it's amazing how much mischief that causes. Or if, for example, if these diodes open up, the positive and negative legs will try to go to the opposite rails. And what's wrong with that? Well, it drives the output transistors full on and one of them's going to short. Or both of them are going to short. And shortly after that, the fuse of the transformer is going to blow because of the short circuit. So when I'm doing some troubleshooting, it's just a technician's tip. I'll replace those resistors with a 3156 audio indicator lamp, side marker lamp, turn signal lamp, tungsten, incandescent. Don't use an LED replacement; it won't work. The reason these are handy is that on that lamp, the cold resistance is about half an ohm or under. So it's about the same resistance as those resistors. And the beauty of that is you can sneak up on the voltage with a variac. If the light bulb starts to light, you know you have a short. And you can test it. Now, obviously, you can't do full power testing with that, but you can use that to keep from burning up an expensive replacement transistor. Say you replace one of the two, although I definitely recommend replacing the pairs. It's just a tip. And since I said they had to be done in 2 and I'm past that, are there any questions? Yes, sir.
I see a lot of people using braid to remove solder.
Yes.
Is there a flux on that braid that draws out?
There certainly is.
There is, okay.
Yes, that braid has a lot of solder. If you want to go after, you use that, you want to go after it with a Q-tip and some alcohol to get the flux off the board.
Okay.
Polish up and clean it up.
Okay, so a certain amount of heat you used to use to do the 440 watts, or I mean, is that too much?
No, 40 watt, well, that's the beauty of the controlled iron. It maintains temperature rather than constant power.
Okay.
So it'll maintain the temperature so you won't get things too hot.
Yeah. A lot of times I'll do it, like you said, I'll use hemostats, hold that, so it's easy to see, but I can get that one area.
Yes, sir.
You briefly mentioned a club name. What's the specific name of the club?
No, the club is the Vintage Electronics Club, Michigan Vintage Electronics Collectors Club.
Okay.
It used to be the Michigan Antique Radio Club, now it's the Michigan Vintage Electronics Collectors.
So what's the average bench speed nowadays for repairs? The average bench speed for repairs are hourly, $70.
Well,
$50.
I'm cheap, I'm retired, and I do it so I can write my articles.
Oh, there you go.
I will leave it up to you to decide what would be reasonable.
So it's an older tube amps, 40s, 30s, stuff like that. Because the voltage was so much lower back then than it is nowadays.
On the contrary, you want to be careful with those 30s vintage audio amps.
No, I mean the voltage coming out of the voltage.
Oh, the
So
the power input voltage.
exactly. So since we've got higher voltage coming in than what they were built for, What is there an issue with that? Because I've actually put some things to drop.
Usually
down.
not. The line voltage, the standard line voltage in the United States has been 120 volts since about 1947. And before that, it was 117 volts. The 110 volts dates to Edison. And then, because Edison was generating at 120, and because he was generating DC, he figured he'd have it to be 110 volts by the time it got to your house.
So can you build an attenuator that take that 120 down to the 110?
You could. If you're too concerned about it, what you can do is you take a 6-volt filament transformer and connect it in buck. So you put the transformer across the line and then connect the windings to reduce the input by 6 volts.
Okay.
If you follow that 6, it's 3 or 6 volts.
That's what I've been dropping down for these things.
Yeah, use a filament, an old
I don't
filament.
know if it's necessary. Is it overkill?
Usually, I have not found it to be necessary. Unless I'm dealing with something really, really exotic now.
Quick question. I noticed that when you talk about, finding information from the web there, obviously we're using Hi-Fi Engine as one of your references, but going to your little thing about the Fisher, do you know of any resource for like mod circuits? Like for example, Heathkit using germanium transistors. Do you know of any like pre-made, okay, let's change this over to,
No,
to
I'm
silicon,
not.
using
No,
this
I've
kind of
got,
thing?
the only one I couldn't, it's only been a couple. I've just replaced it with the standard topology silicon transistors. Just essentially rebuilt the stupid thing.
Because basically, you just gotta redo all the biasing on it, the whole biasing has to be redone to change it over to silicon.
Yeah.
Is there any resource that they've said, hey,
Not
we've
that
done
I
that?
found, not that I found, because those germanium transistors are only used for like 2 or 3 years.
Well, I mean, 'cause like I got a TX reel that's got low signal germaniums, it's gonna have to be all pulled out. And like I said, I got Heathkit to define, the main outputs are, germanium. It'd be nice if I already saw somebody else that had already done this.
And unfortunately, I have not. I'm sorry, I don't know offhand. I'm always a little leery of doing retrofit kits.
Well, that's one thing I'm not gonna sit there.
But there's still Mauser and
Yeah, exactly.
and Altman and
Exactly.
those guys, right?
Yeah, there's still a number of vendors out there, fortunately. Fewer and further between, but there's
Well,
still.
yeah, the electronic connection finally closed over there, it's about the only place around anymore. Locally.
So thank you all for coming.
By the way, what's your name?
I'm John Riding. I was the guy on Channel 7 this morning. So,
Yeah, Mark.